When we think of a giraffe, we picture the towering legs and that iconic skyscraping neck. But their daily survival actually relies on a specialized feeding tool hidden entirely out of sight inside their mouths. Out on the vast African savanna, these massive herbivores sustain their bulk by feeding almost exclusively on the leaves of flat-topped acacia trees. To extract enough calories from these trees, a giraffe has to stretch a highly sensitive muscle out of its mouth and directly into the canopy for up to 12 hours a day. If standard biological tissue were left exposed to the elements and scraped against sharp branches from dawn until dusk, it would suffer agonizing blisters, severe sunburns, and crippling infections. The acacia tree does not give up its leaves easily. The branches are heavily fortified with dense clusters of razor-sharp thorns designed to shred the mouths of hungry grazers. And above the tree line is a second hazard: intense, unfiltered ultraviolet radiation pounding down across the plains throughout the heat of the day. To access the high canopy leaves, a giraffe requires a biological mechanism capable of threading through dense thickets of spikes while simultaneously shrugging off a continuous barrage of solar radiation. The first adaptation is pure reach. A giraffe's tongue measures between 18 and 20 inches in length. It is prehensile, meaning it can wrap, twist, and grip branches like a dexterous fifth limb. This extreme length allows the animal to strip foliage clean while keeping its vulnerable eyes and face at a safe distance from the spikes. As the tongue pulls through the thorns, it relies on a dense coating of tough, bristle-like papillae to resist deep punctures and scratches. If a thorn does manage to pierce the surface, the giraffe produces a thick, antiseptic saliva that instantly coats the wound to kill bacteria and accelerate healing. Length, grip, and chemical defenses allow the giraffe to navigate the physical thorns. But these traits do not explain how the muscle survives the constant threat of the sun. Look closely at a giraffe mid-meal, and you'll notice the exposed tip of the tongue is a deep shade of blue, purple, or black. It is not stained by the leaves it eats. That dark coloration comes from a massive concentration of the biological pigment melanin. Melanin is a natural sunscreen. When UV radiation hits the dark outer layer, dense pigment particles absorb and scatter harmful rays before they damage delicate cells. Because this shield never washes off, giraffes can feed for 12 hours straight without suffering cellular damage or blisters. We can actually see exactly where this protection stops. Further back toward the throat, where the muscle stays safely shaded inside the mouth, the tissue remains a standard fleshy pink. This dark tongue is even shared by the giraffe's closest relative, the rainforest-dwelling okapi, suggesting it is a deep-rooted evolutionary defense. This pigmentation completes the adaptation, turning a vulnerable muscle into a foraging tool capable of surviving the most intense solar conditions on the planet. By neutralizing both the physical threat of thorns and the radiation of the sun, the giraffe claims an entire vertical ecosystem. They feast on a massive food supply completely out of reach to the other grazers below. It guarantees them a steady source of nutrients and secures their dominance in a highly competitive environment. The dark tongue is a specific biological solution to a localized environmental problem, a clear demonstration of natural selection at work. Today, however, the acacia woodlands that define this animal's life are being cleared for farmland or lost to severe droughts. As the tree canopy disappears, giraffe herds are forced to spend even longer, more grueling stretches foraging in the open sun for the few remaining branches. These biological defenses took millions of years to calibrate to the savanna's rhythms, but the habitat is now changing faster than biology can keep up. Nature equipped the giraffe with an ingenious, melanin-rich shield to survive the sun, but even this specialized anatomy cannot save the species if the environment itself vanishes.